Welcome to SAT School. This is our second video on radical and sort. Now let's get started. And this is where we left on last video, that is practice question 2. If you have not watched that video, I strongly recommend to watch that first. Click the I button above and watch the video. Here you have to find the order of this sort. And we discussed earlier, this number represents the order of the sort. Here X is the order of the given sort. So you can write the order is X. Again, this number here in this case X, so this is the order of the sort. There might be 2, 3, 4, 5 or so on. Now here is practice question 3. You have to identify or you have to check the given number is a sort or not. So let's rewind. Sorts are irrational numbers which are roots of positive integers. Here we have some examples of the sort. This is root under 2, root under 3, and this is a cube root of 7. So all these are irrational numbers. We discussed earlier in previous video the irrational numbers. So these are irrational numbers and these all are roots of positive integers. Here this is a square root of 2, 2 is positive integer, square root of 3, 3 is positive integer, and cube root of 7, here 7 is positive integers. So all these are sorts. Now here we have two numbers which are square root of 4 and square root of 9. If you find square root of 4, that is equals to 2, which is a whole number. If you find square root of 9, that is equals to 3, which is also whole number. So when you find square root of any number, if that is equals to whole number, then they are not sorts. Here if you find square root of 2, you cannot get a whole number. If you find cube root of 7, then you cannot find whole number. So simply sorts are irrational numbers, and if you can find the square root, cube root, or that is equals to whole number, then they are not sorts. Now let's come back again. So in practice question 3, we have to identify this is a sort or not. The process is you change that into simplest form. This 27 is equals to 3, 3 and 3. There is multiple of 3, 3 and 3, and the simplest form you can write is 3, that is root under 3. Now here this root under 3 is a sort that we discussed earlier. Root under 3 is a sort, and if you multiply a sort by any integer, that is also a sort. That means this is a sort. So you can write here root under 3 is a sort. That's why the given number is also sort. Now here is practice question 4. Again, the question is to find the cube root of 625 is a sort or not. You have to check. The process again same. You have to change this number into the simplest form, where this is equals to 5 cube root of 5. This 625, that is a multiple of 5, 5, 5 and 5, and that is equals to 5 cube root of 5, and this cube root of 5 is a sort, and the cube root of 5 is a sort. That's why this given number is also sort. So simply if there is any sort and if that sort is a multiple of any integer, then that as a whole becomes a sort. If you can find, when you change the given number into a whole number, then that is not a sort, like we did previous, where where root under 4 or square root of 9 is equal to 2 and 3 respectively. So those numbers are not sort. Now here you have to simplify, meaning change this into the simplest form, and then finally you add or subtract. So you can change this square root of all these number into simplest form. So where 125 is the multiple of 5, 5 and 5. So that is a multiple of 3, 3 and 5, and this is a multiple of 2, 2 and 5. So this is how you have to first change that into the simplest form, and that is equal to 5 square root of 5, 3 square root of 5 and 2 square root of 5. Now here you can add these two numbers because these all are like terms, meaning they have the same radicand here, like 5, 5 and 5. So these are square root of 5, 5 and 5. So these are like terms. Now you can add this 5 and 2, which is 7 square root of 5 minus 3 square root of 5, and that is equal to 4 square root of 5. Now practice question 6. Again, you have to simplify the processes. You have to change this into simplest form, all these number into simplest form, and then you add these two if they are like terms, and finally you subtract again if they are like terms. You just can follow practice question 5. Change all these number into simplest form. If there are like terms, you can add and subtract. I think you can do that. Just follow practice question 5. Now here is practice question 7. The difference is, here is a cube root of 16 and cube root of 250 and cube root of 54. The process is exactly same. You just have to change all these number into the simplest form. Now here again, when you change that into simplest form, so this is equals to this 2 cube root of 2, and this is equals to 5 cube root of 2, and this is equals to 3 cube root of 2. So all these terms, you can say they are like terms because they all are cube root of 2. Now you can simply multiply here, which is equals to 6 cube root of 2, and finally you can add and then subtract. So here this is equals to 9, and when you subtract minus 5, that should be equals to 4 cube root of 2. Again, you can add and subtract if they are like terms, meaning they have the same square root or cube root, or they are root of the same number. Here this is a cube root of 2, cube root of 2 and cube root of 2. So these are like terms. You add these numbers, which is 9, and then subtract 5. Now here is practice question 8. You have to simplify. Change all these number into simplest form. If they are like terms, you can add and subtract. If they are not, just leave as it is. So change all these number into simplest form. If they are like terms, add and subtract, and just follow the previous questions. So you can complete this. I want you to complete this, and this much for today. So thanks for watching. If you have not subscribed our channel, please do subscribe and press the bell icon so that you can get a notification as soon as I upload my next video. Take care.